I think a lot of what we do in the laboratory is as close to translational as can be within the context of a basic science department. We are obviously not a medical school, but we are doing basic science with questions of clinical significance. My laboratory studies mechanisms of addiction and schizophrenia, and in doing so, we are aiming to define possibly pathways that could be exploited through clinical uses, pharmaceutical uses, as a way of diagnosing people, or pathways that could be exploited for drug development. So that's some of the overarching goals of what we aim for. A lot of what we do in the laboratory also is focus on a disease state, but ask very basic questions of how does the brain change during this disease state. And in doing so, we actually are sort of asking indirectly, how does the brain work? And so we're constantly using this, I think of it as a mirror approach. We're mirroring the normal state and the disease state that is a slightly misaligned state of brain functions. And so a lot of what we do actually allows us to understand diseases and mechanisms of diseases by asking very basic questions about how the normal brain works.
Cool.
So I'd like to think that we are actually as close as can be to translational research. And some of the things that we're working on are actually quite translational in nature. Many of the proteins that we're discovering are possibly patentable in the long run if they turn out to be important for a certain disease state like addiction or schizophrenia. We're actually also developing a series of peptides that could go in the direction of drug development. Peptide drug design is actually very appealing for a lot of industry, biotech industry.
Okay.